Alright, what's up? Today we are starting to bring everything together. So the purpose of everything that we've done so far is to get an idea of what a function looks like without actually graphing it. So that's what we're using the calculus for, to figure out where we're increasing, decreasing, our concavity, and we already know a bunch about horizontal end behavior, things like that, asymptotes. And so we are going to bring it all together and start curve sketching. Alright, so first let's run through some limits to infinity because we haven't done that for a while. Right, so remember, if the power on top and bottom are the same, so we're looking at the degree of our function, and if it's the same, we just look at our leading coefficient. So in this case, it'll be 3 over 2. Right, if it's negative, we just have to consider putting a negative number in. All right, so for instance, here, if I put a negative number in, I would get negative 3. If a negative here, it would be negative 2, so negative 3 over negative 2 is still 3 over 2. So in this case, to negative infinity, it didn't really matter. Okay, now if the power on top is greater than the power on bottom, okay, I can think about this as increasing very much faster than this function. Okay, we know a quadratic gets bigger very much quicker than a linear function. And so on top, I'm increasing faster, which means that the overall limit is going to infinity. Right, and similar situation here. So if I plug a negative number in to a squared, it'll be positive. If I plug a negative number in here and put it to the first part, it'll be negative. So I have a positive divided by a negative. I know the answer is infinity. So this time it'll be negative infinity. All right, and let's move on. So now the power on bottom is greater than the power on top. I know that this is going to be a much bigger number. So I'm dividing a smaller number by a much bigger number. It'll approach 0. Right, and for negative infinity, it doesn't really matter. There's no such thing as negative 0. So the answer is still just 0. Okay, now in this case, it's a little bit different. I have to consider the fact that I have x squared to the 1/2 power. Right, so I can't actually evaluate the square root, but I can think about it conceptually as if it was x squared to the 1/2 power, because this plus 4 as a constant doesn't really affect anything. And so this is really like x to the first power on bottom. So I have 2x over what is essentially 1x, so it'll still be 2. Alright, so the power on top is 1, the degree on bottom is also 1. Alright, for negative, so if I plug in a negative number, I'll have a negative 2 on top. And then I have negative squared will be positive, square root still positive, so negative 2 on bottom. All right, and then last one. So here I have a quadratic on bottom, so increasing very quickly. Here I have sine, which oscillates. All right, so x squared is going to get much bigger than sine will. Sine never gets above 1. This has an amplitude of 1. So it'll never get above 1, never get lower than negative 1. X squared will get much bigger as we approach infinity. So I have essentially a constant, or something very small, divided by something very big. This will approach 0. All right, so that's how we can kind of think of these conceptually. All right, now let's bring it together with an actual curve sketching problem. So here's a review on even and odd functions. Essentially, to figure out symmetry, you just plug in negative x for x. If you get the exact same thing back, even if you get the exact opposite back, it's odd. All right, and so odd symmetry is about the origin, even symmetry is about the y-axis. I can explain more about that in class. All right, so first, let's find some asymptotes. So my horizontal asymptotes are going to be limits to infinity. So I'm going to take the limit as x approaches infinity of 3x over the square root of x squared plus 1, exactly like the one that we did above. Essentially, I have 3x on top and just 1x on bottom. So my limit to infinity is 3. When I take the limit as x approaches negative infinity of the same function, okay, I have negative 3 on top, and then a negative number squared is going to be positive. So I have negative 3 on bottom. All right, so here are my horizontal asymptotes. Now for vertical asymptotes, that's where the denominator is 0. Now right off the bat, I can see that'll never happen, because if we set the denominator equal to 0, so this was for horizontal asymptotes, this is for vertical asymptotes, I get this, which is impossible, I get this, which is I don't really care about this. Okay, so if you get an imaginary number, that's not something that we're dealing with. So I have no vertical asymptotes. Alright, then in terms of symmetry, so if I plug in negative x, I'll end up with 3 times negative x divided by negative x squared plus 1, which gives me negative 3x over x squared plus 1. So it's as if I multiplied by my original function by negative 1. I got the exact opposite back, meaning that my function is odd. Right, last things, intercepts. Alright, so I want to know, first of all, where I'm going to be 0. So let's solve for my x-intercept first. So I set 0 equal to 3x over the square root of x squared plus 1. I end up getting x is 0. Okay, now I want to know where my y-intercepts are. So y equals 3 times 0 over 0 squared plus 1, I end up getting 0. So I know that I crossed through the origin. Okay, so let's try to curve sketch this. So I know that I'm going to pass through 0. And I know that my function approaches negative 3 as it gets further and further out to infinity. So negative infinity. So it's going to do something like this. And then as I go to positive infinity, it's going to do something like this. Right, now what odd symmetry tells me is that it's symmetrical about the origin. So for instance, if I draw a point here and I connect it to the origin with a straight line and I extend that line, it'll give me the exact same point in the opposite quadrant with basically the negative coordinate. So if this, for instance, was like, so if this, just for example, was like, I don't know, 4, 2. I know it's not, but just for example, if it was like 4, 2, then this point would be negative 4, negative 2. Alright, so that's what odd symmetry tells me. Alright, and so just in case you're curious, because I know you all are, if we look at the actual graph, it does look very similar to what we said it did. So it goes to negative 3 as it approaches negative infinity, positive 3 as it approaches positive infinity, and it crosses through the origin. And it definitely looks odd. Alright, so that's it for these notes. See y'all later.